Now let's go ahead and do some examples of confidence intervals. And yes, I am going to show you a TI-84 shortcut to calculate confidence intervals. Remember, when you're doing free response, you need to show all the work that I'm showing right now. If you're doing multiple choice, go ahead and use a TI-84 or any calculator to calculate it as much as you please. All right, so we're going to complete the state plan and do and conclude steps based on my attendance example. So I didn't really tell you what percent confidence I wanted, so we'll just default to 95% for now. Most times they're going to give you the confidence level. And so I'm going to say I want a 95% confidence interval for the difference in proportions for Wednesdays and Fridays, where the proportion for Wednesday is the true proportion of students present on Wednesdays, and the Friday one is the true proportion of students present on Fridays. My plan is to do a 2-sample z interval for P1 minus P2. You need to tell me which method you're using, so this is part of your answer. After that, you check conditions. But we actually just checked conditions in the previous example, so we don't need to do that again. Now let's go ahead and get to the do part. Well, my point estimate is just the difference in the two proportions, or 0.047. And since I'm using a 95% confidence interval, our critical value is 1.96. So I can kind of jump to this shortcut where I take my point estimate plus or minus my critical value times my standard deviation. Now remember, since this is 2 samples, here's proportion 1 over N1 sample size and proportion 2 over N2 sample size. So you have the product of P and Q over the different N's. And I end up getting these numbers. So what conclusions can I come to? I can say that we are 95% confident that the interval from negative 0.057 to 0.150 captures the difference in these two proportions of students who attend on Wednesdays and Fridays. By the way, because the confidence interval includes 0 as a plausible value, I really don't have convincing evidence that the proportion of attendance on Wednesdays is higher than that on Fridays. So let's go ahead and show you the TI-84 shortcut. I'm going to use the same example. You're going to basically press stat and then test. All right, scroll to 2-prop Z interval, and we're almost there. There it is. And then hit enter, and then you're prompted for the number of successes, sample size, which I'm putting in 86, the successes in sample 2, and that sample size, and all have to be integers or you will get an error. The C level is the desired confidence level in decimal form. Don't try to put it in percentage form. And you basically scroll to calculate and press enter. And you can see the values. Here's my interval here. There's P1 for my first sample, P2, and it shows N1 and N2, although I already knew that. So let's go ahead and look at the next example. In December 2002, Consumer Reports reported a study on the presence of bacteria in packages of chicken sold in supermarkets. Go ahead and create a 90% confidence interval for the difference in contamination between Tyson and Purdue chicken. So Tyson found Campylobacter contamination in 56% of 75 packages. Purdue found it in 33% of 75 packages. So first of all, let's state what we need to find, which is a 90% confidence interval for the difference in these two proportions, where P Tyson is a true proportion of Tyson packages found with this contamination, and P Purdue is the proportion for the Purdue packages. And now we'll go ahead and do our plan, which is a 2-sample Z interval for P Tyson minus P Purdue. And it's good to go ahead and list labels like this in context. It makes it real clear you know what you're talking about. Now let's check the conditions. We've got large counts. So for Tyson, I did 0.56 times 75 is 42 successes. 75 minus 42 is 33 failures. Purdue, 0.33, doing a third is 25 successes and 50 failures. For random, it's safe to assume that Consumer Reports knows how to take a random sample that would be representative. And 10% condition, 75 packages is definitely less than 10% of all Tyson or Purdue packages. Now let's go ahead and do the calculation. So we have P Tyson minus P, the proportion for Purdue, 50.56 minus 0.33 is 0.23. I'm doing a 90% confidence interval, so the critical value is 1.645, and I found it by doing 1 minus 90 to find the outside pieces, and then dividing it by 2 so I can just find that left side piece, all right? And my confidence interval is my point estimate plus or minus my critical value times my standard error for my sample. In this case, 0.56 is in this fraction here with 75. And then I have 0.33 in here with 75 because both the sample sizes are the same, which gives me this interval value right here. From negative 0.0133 to 0.2533 is the difference between these, well, that we're 95% confident that that's the difference between those two intervals, which we write this way. We are 90%, sorry, we only did a 90% confidence interval. We are 90% confident that the interval from negative 0.0133 to 0.2533 captures the difference in the true proportions of Tyson and Purdue packages with Campylobacter contamination. Now, by the way, this one also includes 0. So we don't really have evidence that one is really higher than the other. One last example. We're going to go ahead and look at a support group. We're looking if a support group helps people who are wearing nicotine patches to quit smoking. So we're going to create a 95% confidence interval for the difference. And I have group 1 that wore the patch and attended weekly meetings. So that's a support group. And 46 out of 153 successfully stopped smoking. For group 2, they wore the patch, but they didn't do the support group. And 30 out of 151 successfully stopped smoking. So my state is I'm going to do a 95% confidence interval for P1 minus P2, where P1 is a true proportion of those who wear a patch and attend weekly meetings who successfully stop smoking. And P2 is a true proportion of those who only wear a patch and successfully stop smoking. It might be tempting to say group 1 and group 2, but I actually technically already know that. That's not the whole population. These are just, it's an experiment, so I'm not representing the entire population. So that's why I was very specific here on the wording. Now let's go ahead and start on the plan. First, the method we're going to use is a 2-sample Z interval for P1 minus P2. Now let's check conditions. The large counts condition is met because I have 46 successes out of 153, which means I have 107 failures. Both of those are easily greater than or equal to 10. Same thing for group 2. I've got 30 successes and 121 failures, also greater than or equal to 10. I have the random condition, but in experiments, if you randomly assign, you're fine. You've met the random condition. As far as the 10% condition, not so applicable to experiments because I could keep doing things over and over. Replacement's not really an issue. All right, so let's go ahead and do the do part of the calculation, which is we're going to do first our point estimate, proportion 1 minus proportion 2, and you can see how I created the fractions, 46 out of 153 and 30 over 151. Subtract those two and I get 0.102. Now I'm doing a 95% confidence interval, so the critical value is going to be 1.96. And to calculate the interval, it's the point estimate plus or minus your critical value. And then you have this ugly standard deviation because we have the difference of two proportions. Just make sure you have each proportion in corresponding to its sample size. So I have 0.301 and 153 here. I have 0.199 and 151 there. After I run that through, I get these values for the confidence interval. And what can I conclude? Well, basically, I can conclude that we are 95% confident that the interval from 0.0054 to 0.1986 captures the difference in the true proportions of those who stop smoking when wearing a patch and attending weekly meetings versus those who only wear a patch. And because the interval doesn't include zero's not in there, as a plausible value, we actually do have convincing evidence that wearing that patch made a difference. And, well, I'm sorry, wearing the patch and attending a weekly meeting makes a difference even compared to just wearing a patch in the success rate for stopping smoking.